Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today we are going to talk about machines. Any machine serves basically two or three purposes. One, that if I can lift a load of higher value by applying lesser effort, then machine is useful for me. Okay. Another advantage of the machine would be that if I have to change the direction of application of the force, like pulley is one example where we are using the pulley to change the direction of application of effort, which makes our life easy. So machine per se is used to make our life easy by applying lesser effort, or by using it as a change of direction, or by using it for improving the velocity ratio, that with the load arm moves higher, the effort arm moves lesser, and that way we will be able to execute more work on the load side. So there are these 3 or 4 different reasons why we use machines, which makes our life easy, right? Now there are few technical terms involved related with any machine. The first one is mechanical advantage. Mechanical advantage is defined as the load divided by the effort. If suppose I am able to lift L Newton load by applying E amount of effort, that is lesser force, then I am getting mechanical advantage. Suppose I am able to lift 100 Newton equivalent of force by just applying 50 Newton, then 100 by 50 will be 2. So mechanical advantage is 2 times, right? Similarly, there is another term in context of machine is defined as velocity ratio. Velocity ratio is velocity of the effort arm divided by velocity of the load arm, right? On one side, you will be applying, suppose there is a maybe a scissor or lever or anything of that sort, and then or maybe even you can take the example of pulley also, that there is a pulley and you are applying on one side, you are applying, there is a load, and on another side you are applying effort in this direction. So you are, by applying this effort, you are able to move the load. So suppose your load moves by dl distance upward and your effort moves dE distance downward, right? And in the same time t, if this movement happens, then the velocity of the effort arm is dE upon t, and velocity of the load arm will be dl upon t. If you just cancel this d and t, you will be finding the distance covered by the effort arm dE divided by the distance covered by the load arm. So that's how velocity ratio is defined, that distance covered by the effort arm divided by the distance covered by load arm. Okay. The relation between mechanical advantage and velocity ratio is mechanical advantage is equal to velocity ratio multiplied by efficiency. Let us look at how we get this relationship. So for any machine, for example, the pulley, the efficiency is defined as work output by work input. Okay. In an ideal machine, howsoever work I am doing on the machine, and machine is giving me certain output. Ideal condition, whatever work input I am providing to the machine, I am getting the same work output. That is the ideal condition. So in the ideal condition, the efficiency of the machine will be equal to 1 or 100%. Okay, but practically it never happens that whatever effort I applied on the machine side or whatever work I did on the machine, that is input of the machine, I get exactly same output. Because of the friction and all other factors, the output of a machine will be always less than the work input in a practical machine. Okay, this is the ideal condition that whatever input I applied to the machine, the same amount of work output I got. Okay. So this is the definition of efficiency. Now if you extend this, then on the work's output side is practically the load side, and work input side is practically the effort side. So then basic definition of work will be the load in Newton multiplied with the displacement of the load. And on the effort side, the work input will be the effort in Newton multiplied by the displacement of the effort arm, because that is the basic definition of work, that work is equal to force multiplied by the displacement of the point of application of force, right? So from that concept, on the output side, that is on the load side, load multiplied by the DL is the work output, and effort multiplied by the distance of the effort will be the work input. So from that we can write that this is L by E multiplied by, I can bring this DL down and I can write this as dE upon dL. Now if you carefully look at the definition, the mechanical advantage is load upon effort and velocity ratio is dE upon dL. So from this definition then, this value can be replaced as mechanical advantage and this value can be replaced as velocity ratio, because velocity ratio is equal to dE upon dL. And from them, then we can write that mechanical advantage of any machine is equal to velocity ratio into efficiency of the machine. Okay. So this is how we connect the technical terms related with the machine. By this video, you have been able to understand that what is mechanical advantage of the machine, what is velocity ratio of the machine, and how mechanical advantage, velocity ratio, and efficiency of a machine are related. Thank you.